2, we're going to graph some sine curves that have a little twist to them. We're going to do some transformations. 3 sine 4 theta, what the idea here is that you're going to try to see what the 3 and the 4 do. So would you all on your iPads go A, B, C, and D, like that? These are constants that we're going to find in this equation. A is in front of sine, B is in front of the theta, and we're going to see that there's going to be a shift plus or minus C here, and then we're going to have a D, but we're not going to worry about that quite this yet. We'll just kind of wait on that. So A is 3 and B is 4. C we don't see yet, neither is D. There's 2 things that we're going to identify. One is called the amplitude. That's how the vertical stretch is. And in this case, it equals A. So the amplitude is 3. The period is the next thing we're going to find. And the period is it helps you find how far it is on the X to do one cycle, to do one complete cycle. So to do one cycle, it goes 0 to 2 pi normally. But if you see a value here, a B value, that's going to have decreased how long each cycle is going to be. So in this case, what's 2 pi over 4? Pi over 2. Okay. So let's sketch this. We can do it. We'll start by drawing the sine curve. Well, that basic sine curve. Sine of 0 is what? 0. Go up, down. Just draw one cycle like that. Just make a little sketch. How high does it go? 3, right? 3 is how high it goes. How low does it go? -3, because there's your amplitude. Goes up to 3, down to -3. Normally it just went to 1 and -1, but now it's going all the way up to 3 and down to -3. The completed cycle of this one is going to be pi over 2. And I like to put the halfway mark in there, pi over 4. Ta-da! There it is. Pi over 2 is your completed cycle because of the 4, and 3 is how high and how low, -3, that it goes. Just a quick comment about 4. This is the way I like to remember it. This is how many cycles between 0 and 2 pi. So if you see a 4, there's 4 cycles between 0 and 2 pi. A mosquito beats at 550 cycles a second. So if you were to graph the wing movement, you would go up and down per second for 550 times. This is a real helpful graph. Let's have you try one. Go to the next slide. 4/5 cosine pi theta. A is going to be what? What's in front of cosine? 4/5. You just put in a 4/5. What's B, the number in front of theta? Pi. Yeah, that's weird, but you can do it. I don't see any shifts yet. So the amplitude is just going to be the A. Period is 2 pi over B, and B was pi, which is going to be kind of cool. What is the period for this, for one cycle? 2. That'll be easy to graph. And these will be 0 so far, because there's no C or D. What's the cosine of 0? Cosine of sine of 0 is 0. Cosine of 0 is 1. So normally this would go up to 1, come down, go back up to 1 again. But what's the amplitude of this one? 4/5. So you put in a little 4/5, -4/5. And then one complete cycle is 2. Half a cycle will be 1, a half. If you wanted to keep going a 1/4, you could, but you don't need to. And there we did it. We graphed 4/5 cosine theta. So what about a shift? Well, we're going to do a horizontal shift on this one. I want to give you a little warning though. Warning, you got to factor first. So I'm going to rewrite this right above here. Would you do it with me? 12 sine. I'm going to factor out a 2 out of here. So that's easy. Theta is left behind. What will be left here? I used to be confused with this, but here's what I do. 2 times what is equal to pi over 6? Yep, you're going to divide by 2 and you're going to get the blob here is pi over 12. So theta plus pi over 12. Does this help a little bit? So then when we list things, what's A? A is 12, B is your 2, C is your shift. What is it? Pi over 12. It's got to be this one here. Pi over 12. And since it's plus pi over 12, is it left or right? Left. Just like it was before. And I don't see any up 1 or up 2 or down 3. What's your amplitude for this one? 12. And the period is 2 pi would be a normal cycle over 2. So 2 pi over 2 is just going to be pi. And we've seen this one before. So let's sketch this with the phase shift. So we'll start with the sine of 0, which is, draw the sine curve. What's sine of 0? 0. There you go. Sketch that. How high does it go? 12. Goes down to negative 12. Great. 1 complete cycle is how far? Pi, right? The middle is pi over 2. Middle of that, pi over 4. Middle of that, pi over 8. Gives you an idea of how little pi over 12 is. So then I'm going to go to, oh, I'm going fancy town here. Okay, there's the curve the way it is now. I'm going to move left or right. It says left pi over 12. So if this is pi over 8, pi over 12 is about a little more than half that. It's only a little bit. Kind of look about, something about like that. And you could keep drawing this in both directions if you wanted. This doesn't stop in either direction, but one cycle is good enough for me. So that's how you draw an amplitude period and a phase shift for sine and cosine.